Hi, everyone. Is everyone able to hear me? Cool. Good morning. Thank you for being here at this 10 a.m. session directly after the keynote. As Giovanni said, my name is Alesha Unpingco. I'm a user experience designer for virtual and augmented reality at Google. And today I'm going to be talking to you about designing for AR. So specifically, the type of AR that I'm talking about is mobile AR, not HMDs this time around. And the thing that I want to point out here is that Google has a very long history of designing for AR. Many of you guys know this, but we've been doing mobile AR for the past 4 years and working on other AR projects long before that. And what's changed most recently is that mobile AR is really starting to take off. And Google's AR Core makes it possible for anybody to create quality augmented reality content. So if you haven't heard about AR Core already, I'll give you some fun facts about it. We launched 1.0 earlier in February this year, and this made AR content available on more than 100 million devices, and we're already seeing really fast growth with more than 340 apps already available on the Google Play Store. So I'm going to talk to you this morning about designing for AR. And what we found is that once you understand your users and you know the type of app that you're trying to create, design principles for getting started in AR design fall into 5 different categories. And we call these categories the pillars of AR design. They're pretty simple. The first one is understanding the user's environment. So when it comes to the environment, think of where the user will be experiencing your app. You want to think about the surfaces that are available and how your app can respond and adapt to different environmental constraints. You also want to think about user movement and how much space the user needs in order to get the full experience from your application. We talk about initialization, and this is really onboarding the users so that they understand exactly how they can interact in this completely new medium. And when it comes to interactions, one of the things that you want to do is make sure that your interactions are intuitive and that you're communicating the right visual affordances and feedback so that users understand how this AR content fits in the context of their real world. We have some interesting considerations when it comes to user interface design in mobile AR. You can think of on-screen UI and also volumetric interface design as well. So I have a couple examples about each of these pillars. And with this framework, we believe that it will help anybody get started in creating quality AR content. The thing that I'm going to point out before diving into each of these examples is that many of the animated GIFs that you'll see in this talk will be available through a playable app called AR Core Elements later this summer. And much of the code is already available in Google's library called SceneForm, which makes it easy for Java developers to start spinning up AR content. And all of that code for the core interaction patterns that you'll see here will also be available in Unity later this summer. So I'll dive right in. We have understanding the user's environment as the first pillar. And before getting started deep into this, I'll talk a little bit about what AR Core can do. So we have a couple cool features. One of the things that people commonly understand is AR Core's ability to detect surfaces. So this is surface plane detection. We can detect horizontal surfaces like floors and tables, but we can also detect walls and vertical surfaces. More than that, we can detect oriented points and angled surfaces. And we also have light estimation. So this allows objects to appear realistic in your scene. We have cloud anchors. This is a really new technology that we released earlier this month at Google I/O. And what it is it's multiplayer capabilities that works across iOS and Android devices. So people can get shared content and see the same items in the exact same space. We have augmented images. And what this does is it allows us to recognize images and get 3D pose data off of those images. And the reason why we're working so hard to expand the features for AR Core is because the more that your system and your phone understands the world, and the more that developers and creators like yourselves are using that information in order to build quality experiences, the more magical your app is going to feel. So I'll talk about surface plane detection. And a lot of people use just one surface for AR. You might have a tabletop game and it only needs one small surface in order to be successful. But there's really no reason why you need to feel constrained to one surface. you can leverage multiple surfaces in your environment or in the user's environment so that the app feels like it's smartly reacting to the different surfaces in the user's space. So consider leveraging multiple surfaces and using that to your advantage when you're creating your apps. We have light estimation. So again, this allows content to appear realistic and really blend into your user's physical space. And there's some really cool things that you can do here. So here are examples where we have 3 fake plants and 1 real plant on the far right. And they show 3 different types of lighting techniques that you can apply to your objects. We have unlit, which is the most basic form of lighting that you can apply. We have dynamic lighting, and that allows real-time shadows to be cast by some of these objects. And we have a combination of dynamic and baked lighting, which allows some of the leaves that you see at the bottom of the succulent appear more realistic. So here's an example of that in motion. And you'll notice that as the phone moves around the scene, you're able to see how those 3 different lighting techniques play out on the succulent that you see here. So another thing to point out is that as the scene gets darker, the environment gets darker, the unlit object doesn't respond as well. So those are some really smart techniques that you can apply when it comes to lighting. We have that all baked into our API and AR core. But you can also use lighting as a trigger. So here's something smart something really cool and fun that we are playing around with, where the city scene is reacting smartly to the lighting conditions in the user's physical space. So when the user flips off the switch in the room, the city lights up and the car lights get brighter. So you can also use lighting as a trigger. We have oriented points, so again, that allows objects to react to the angled surfaces in the user's environment. And here's an example of that. It allows you to get all of the different feature points, so that as the user taps on the screen, they're able to place the androids at the correct orientation on the area of the branch that they're interested in. And I mentioned cloud anchors earlier. This is, again, our multiplayer sharing and persistence API that makes it possible for users to see the same content and engage in a shared experience across iOS and Android devices. So here's an example of a demo app that we worked on and released at Google I/O earlier this month. 2 players are seeing the same thing, and they're also using an iPhone and an Android device in order to engage in the same game. So what we found is that when you take advantage of all of these different features, you're able to make gameplay more fun, more immersive, more engaging, and more social. I mentioned augmented images. So again, we're getting 3D pose data off of these images that we recognize. So there's some really cool experiments that I'm able to show you here, where we've created an interactive art exhibit. And here's an example of that. So whether you use AR Core's augmented images to create an interactive art exhibit, or you do something a little lower fidelity, like making the front of a product box come to life, there are so many different possibilities that we're excited to see people experiment with when it comes to augmented images. So now that we know what AR Core is capable of, we can start thinking about how to begin your design process. And many of us think of our brainstorming process as beginning on an empty sheet of paper with a pencil or a pen and thinking through the different screens that you're about to design, how one screen will link to the next. But with AR Core and mobile AR in general, we recommend that you think of the environment outside of the user's phone. So AR exists outside of the phone, so your design should exist outside of the phone as well. Here's an example of that. We recommend that you put away your 2D UI stencils because it's more important for you to sketch the user's surrounding environment. You want to understand the living room space, the area where they're going to be engaging with your app, This helps you be more thoughtful as a creator so that you can think through ways that your app might adapt to the different environmental constraints and think through the different opportunities that you have to really make the AR content come to life. So sketch the surrounding environment and the different AR objects that would be present there. You also want to sketch the users for scale. This not only helps you as a designer or developer, because you're able to see how the user scale or how the user size in relation to the AR content that they're interacting with, but it also helps you when you're collaborating with other individuals so that they don't get the wrong impression when they're working through creating this app. So now that we understand the environment and some of the things to think about there, you also want to consider user movement and how much space the user needs. So as I mentioned earlier, it's completely okay to design beyond the bounds of the phone. And in a lot of ways, that can be very delightful. So when you have objects that appear on screen, but then extend beyond the user's screen, it can be a natural way to get users to move their phone around so that they can understand the exact scale and true size of that AR content in their physical room. It can also feel immersive because users get a sense that that object is really there. So I mentioned how this can motivate users to move their phone around, and that brings me to our next observation, which is that many users for any mobile application aren't used to moving their phone around as a core part of the interactions. It doesn't feel natural, it kind of feels a little weird. So one of the things that we have to think about as creators is how we're going to motivate users to start moving their phone around their physical space if the app requires it. So here's an example. We use characters or animations or objects, and we have them convey visual interest on screen. But very quickly, we have them move off screen so that users are motivated to follow it. In this specific example, we have a bird, and as it flies off screen, it's replaced with a marker. And then you'll notice that the marker slides along the edge so that users understand the bird's position in relation to them. And whenever you have an experience that requires users to move around, think of how you're going to communicate to the user how much space they're going to need. So environment sizes and experience sizes tend to fall into 3 different areas. We have table scale, we have room scale, and we have world scale. And with table scale, it allows users to engage in AR on the smallest of surfaces. With room scale, it expands the impact that AR can have by making objects feel a little more life-sized. And with world scale, we have no limits. It allows users to experience AR in whatever area they see fit. And more than that, when designing for world scale experiences, it can seem daunting and seem like a really big task, but there are a lot of really cool things that you can do with procedurally generated content to make world scale design feel more achievable. So no matter what experience size you decide to go with, you really want to be clear about how much space the user needs. And that's because it can be very frustrating if the user starts engaging with your app and then realizes in the middle of the game that they don't have enough space to play. So don't scale fail. And there's really no one-size-fits-all solution when it comes to experience size. It really depends on the goals of your app and the type of experience that you're trying to create. For example, if you have a game, it might be really interesting to use proximity and user movement as a core part of gameplay. There are cool things that you can do here, like as the user moves the phone closer to the frog could leap out from behind the mushroom, or the mushroom could disappear. But if you have a utility app where the main purpose of the application is to communicate very complex sets of data to all users, it can be very frustrating for the users to be required to move around. What it means is that users with different environment or movement constraints wouldn't be able to get the full experience of the app. So in this case, you might want to allow users to use different gesture controls in order to manipulate the items so that they can place the items and scale it so that they're able to digest content in the way that they think is appropriate. So initializing into AR. What this is it's basically onboarding users so that they know exactly what to do, and they're able to get a successful AR experience. So we're starting to develop standards around this. We want to make it very clear to users if they're engaging in a 2D app A shopping app is a really good example, and they recognize that 2D or 3D content is available. We have an icon, and it's called the View and AR icon, and we're starting to see it show up in many different apps. And what it does is it communicates to users that as they're scrolling through a page, a gallery of different items that they may want to purchase, they see this icon that appears on the UI cards or a floating action button, as you see on the bottom right there, that helps users understand that they're about to enter an AR experience. So we're starting to see this show up in a lot of apps, and the whole purpose of this is to communicate the right expectations to users. Another thing that you've probably seen if you played with any mobile AR apps is this animation. And it's not immediately clear to users why this might be necessary, but one of the things that's really important here that we're trying to do is we're trying to get the user to wave the phone around. That's because as humans, we have two eyes, and that helps us understand the context of the scene. We get a lot of depth information because we're present. We move our head just a little bit, and we get a sense of how far and how close objects are. So we need the phone to be able to do the same thing. The limitations of the phone is that a lot of phones on the market have only one camera on the back, which is the equivalent of having one eye. What that means is that if your phone sees an image like this, it thinks, well, that's interesting, but I don't really know how big this individual is in relation to the object that she appears to be holding up. But the moment you move your phone around just a little bit, you get a lot of information in regards to how far away that object might be. So this animation is very important. It gets users to do the right thing, and very quickly, you're able to set up the correct experience for your user. So the other thing that you want to consider when it comes to initialization is helping users easily move AR objects after placement or communicating if these objects will be persistent in their world. So there are two categories for this. We have persistent objects and we have movable objects. And the whole goal is setting the right expectations for users. So I'll show you some examples. When a user anchors a persistent object, an example of that might be a game where the user is able to manipulate cars in a city. And what she wants to do is she wants to set up her game space. So in this case, she wants to anchor and lock her experience to a certain area of the floor where she knows that she's not going to run into anything, and she's able to get the complete experience there. So once the user is able to place the game board, then she's able to start interacting individually with the cars in the scene. But for items that are less persistent, where the user wants to place something in her scene but doesn't know exactly where she wants to leave it yet, you want to convey to users that they're adding something, but they're not committing to its placement in the world. So here we use a plus icon to demonstrate that. And now that we understand how to place objects, we can start talking about the interactions when it comes to them. One of the things that's really important for AR is communicating to users whether or not collisions with objects is an intended behavior or something that's not really encouraged for the purposes of your app. So here's an example. What we recommend is if collisions with a digital object is not encouraged with your app, use filters or some sort of special effect to discourage users from engaging in that behavior. Sometimes users collide with an object intentionally or unintentionally, and what typically happens in many mobile AR apps is that that object will disappear, and users won't know what happened. They get a little freaked out. So if you have some sort of filter like this, it helps users understand, oh, you might have messed up. Maybe you didn't mean to do this, but it's really easy to bring it back. The other thing that you want to think about is when placing objects, communicate the right feedback to the user. So we communicate surface feedback. You see that with the dots that appear along the table there. And surface feedback is really important because it helps users understand what AR Core understands about the surfaces in their environment. And when you're dragging an object from one surface to the other, maintain the height of the tallest surface until the user lets go. You'll notice that as the user is moving the object from one surface to the next, we have this spotlight effect with that surface visualization that demonstrates the drop point. So always visually indicate the drop point to users so they know exactly where that object will land. And when a user does release the object and places it into the world, we also recommend including feedback to reinforce that object's entry. It also reinforces to the user which surface the object landed on. You can also use gallery interfaces to handle object placement as well. So here we have screen UI, where the user is able to take an object from the bottom bar and drag it onto their scene. And the cool thing about this is that it communicates very clearly to users in a way that they're familiar with how you might be able to place AR content into your world. And not only that, you'll notice that with this type of object manipulation method, it's also supporting very familiar gestures for the users. So they're able to drag an object to place it, pinch to scale, twist to rotate. And direct manipulation of objects works really well and can feel very intuitive. But the challenge is that as you're directly manipulating objects, a lot of times the user's hands will be covering most of the screen. So if it's important for the user to see the screen, since it is their magic window into their world, you wanna consider whether or not reticle selection might be a more appropriate method. So here's an example of that. We have the reticle in the center. The user can use an action button in the bottom right in order to pick up and move the object. And not only that, the user gets a very clear view to the floor and the different table surfaces that are available. So reticle selection is really interesting for these types of use cases, and also for selecting very small objects that would be difficult to select otherwise. The other thing that you get with reticle selection are raycasts. And raycasts can do a really good job at simulating virtual weights. So here's an example of that. We have two objects, a rock and a feather, and when the user picks up the feather and moves it back and forth, you'll notice that the raycast for the most part remains straight. And let me go back to that slide real quick, and when the user picks up the rock, you'll notice in a little bit that there's a more dramatic bend to the raycast to communicate that the rock is much heavier than the feather. So again, this is something that would have been very difficult to communicate if you had used direct object manipulation or direct selection to manipulate these objects. So we have volumetric interface design. I mentioned that you can consider screen UI or volumetric interface design to use in your application. And like I mentioned, the phone is the user's viewport, so try very, very hard to not obscure their view. Here's an example, a good example and a bad example of lots of UI on the screen. So try not to include lots of UI on the screen. What we found is that a lot of times designers or developers get very creative and they try to make the main action item stand out on the screen. But what happens is that users feel so immersed, they're looking out at the content in their world, and a lot of times they lose sight of the objects that are directly in front of them. So don't obscure the user's view with 2D UI, because it can take the user out of the experience and it can also impact discoverability. So it doesn't mean that you can never use on-screen UI, but what it tends to be good for are controls with a high frequency of use and controls that require fast access. So we use the camera shutter button as an example of something that meets both those requirements. We talked about transitioning users from 2D to 3D, but what about transitioning users from 3D back to 2D? What we recommend here is that all of those types of actions, the transition from 3D to 2D, should be initiated by the user. That's because it can be really annoying if the user is completely immersed in your app, and then all of a sudden they get a 2D pop-up, and they kind of don't know what to do. So try not to do that, please. The other thing is that you can use 2D mobile design best practices to inform how you design your mobile AR applications. So an example are finger-sized touch targets. We have two tennis balls. The dotted white line around each of the tennis balls represents the touch targets. And you'll notice that on the tennis ball on the left-hand side, the touch target gets much smaller as the tennis ball moves away. And then it remains the same size for the tennis ball on the right. And if you imagine that you're using direct manipulation to move an object off into the distance, if you have its target area that gets smaller and smaller as that object gets smaller and smaller, what it means if you have to bring that item back is that you're making the user physically walk over to where they place the object, pick it up with the finger, and then resume back to their point of origin. So consider minimum size for touch targets so that users are always able to engage with the objects that you want them to engage with. So we talk about scene over screen. That's something that really guides our team when we're designing for mobile AR. So I recommend that you consider that in your designs as well. Volumetric UI is something that you want to consider because it helps users remain immersed. And I have an example of that. We have a solar system, and the whole purpose of this is we're using the magic window to give the users the widest view of all of the planets orbiting the sun. And with volumetric UI, what you're able to do is you're able to make sure that the users remain immersed so that when the user sees a planet they're interested in, they can just select it and see an annotation appear and kind of track and move with the objects. More than that, if the user selects the sun, the other thing you're able to achieve with volumetric UI is that you're able to launch a settings panel that allows users to make changes in real time, see those applied to the items in their scene, without ever leaving AR. So this is recommended because AR presence is a real thing. What we've noticed in many user tests, I mentioned that users feel very immersed, they see the content out into their scene, and oftentimes what they'll do, especially when placing objects out into the world, is sometimes they'll place it on a surface, then they'll peek out from behind their phone to make sure that everything's aligned correctly, and kind of laugh because they realize that what happened and that object wasn't really real. So if that happens to your app, and it may happen because we've seen it happen quite often, it usually means that you're being successful and that you're making users suspend their disbelief, so they're no longer actively tracking what's real and what's not. So again, we have these 5 pillars of AR design. You can use this framework to get started and start creating experiences that everyone can enjoy. So I have a quick video. Here's what some creators in our community have been creating and developing, and I hope you enjoy. Thank you. To see more and to learn more, you can visit our resources online on our dev site and also our design site. And please keep us posted about what you create. We're happy to take a look, provide feedback, and share them out. Thanks, everyone.